Hey everybody, this is Unit 2 Formative 1, Video 4, Compound Inequalities. Okay, so when we're talking about a compound inequality, we have two different ways we can represent the compound inequalities. It's with an AND statement or an OR statement. So typically when you see an AND compound inequality, your graph is going to look something like this, where you have a circle and your two lines are connected. So your graph would look something like this. Your answer would be an X in the middle with two numbers on the other side. So that would say that X is less than 10, but it's greater than 2. Okay, so that would be all your solutions then. So like before, when we had an inequality, our solutions were infinite. When we have an AND compound inequality, our solutions are just going to be between two different numbers. So in this case, our answers would be between 2 and 6. Okay, when we have an OR compound inequality, your graph will look something along these lines, where you have a circle on one number going to positive infinity and a circle on another number going to negative infinity. Okay, so the number of solutions for an OR compound inequality is still infinite because all your answers going to negative infinity and to positive infinity. The only solutions that it doesn't include are the few numbers in between the two circles. And when you write out an OR compound inequality, it would just be X is greater than 6 or X is less than or equal to 3. All right, let's do a couple examples here. So we have -3, -2, we have -1, we have our number line, and we have arrows going in two different directions. So what I want us to do here is write the compound inequality and write it in interval notation. So first of all, if you remember back from the last slide, this one looks like an OR compound inequality. So we're going to have two statements that have OR in between. Well, our first part here, we're just going to look at this right here, and X is less than -2. Okay, or we could say X is, for this part right here, X is greater than or equal to 2. So there's our compound inequality. And if we want to do interval notation, it works a little bit different. So we're going to actually do the interval notation for this part right here first. So it would be from negative infinity, comma, to -2 with a parentheses, and then the words OR in between again. And then we have a closed circle, so it would be bracket 2 to infinity. Okay, so really an OR compound inequality is just putting two inequalities like we've been doing just together with the words OR. Okay, this interval notation came from this part, this interval notation came from this part. Okay, if we look at our AND one down here, okay, we know it's an AND because the two circles are connected now, meaning our solutions are only between -7 and -4. All right, so when we write that out, we know there's going to be an X in the middle, and we know X is, based on this right here, it's going to be, these numbers are less than -4. So we're going to say less than -4, not equal to because it's an open circle. All right, and then on the other side, okay, we have -7, and these numbers are greater than -7, so we want to say greater than -7, and it's greater than or equal to because there is a closed circle. Okay, so it's really just two inequalities kind of smushed together and using only one X. So this part right here says X is greater than or equal to -7, and this part right here says X is less than -4. All right, and then to do our interval notation, it goes back to only one little bracket in parentheses, so our numbers are between -7 and -4, so we're not going to use an infinity symbol. We're going to go bracket -7 all the way to -4, and -4 is not included, so we want to use a parentheses. Okay, so here all I want to do is draw the graph based on this. So if we draw our graph, we want to go from -1 to 4, So negative 1, 0, 1, 2, 3, 4. And x is between negative 1 and 4. This is an and statement. So it's going to be a closed circle on negative 1, and it's greater than negative 1, and it's an open circle on 4. So it's less than 4, and we're going to connect the two. Your interval notation would be bracket negative 1 to 4 parentheses. All right, and the next one here, we want to go from negative 3 to 3. All right, and it says n is greater than 3, so open circle with an arrow to the right, and or n is less than or equal to negative 3, so closed circle and less than would be to the left. All right. Okay, so here we are actually going to solve some compound inequalities, okay? And to solve them, we're basically just going to look at it like an actual equation. So we're going to look at this part right here. Ignore the greater than negative 11 part. But we have x plus 3 there. So how would I get rid of plus 3? Well, I'd subtract 3. So I'm going to subtract 3 from the negative 8. Well, if I subtract 3 from the middle, okay, I'm also going to need to subtract 3 from this side over here as well. So I need to subtract 3 from both sides of the inequality. So I'm going to subtract 3 here as well. So it's almost like you're doing two equations in one. Negative 8 minus 3 gives you negative 11. And negative 11 minus 3 gives you negative 14. Okay. So now let's graph it. We have negative 11, negative 12, negative 13, negative 14, negative 15. Okay, so this says x is less than negative 11, so we're open circle, and we want an open circle on 14 as well. And it says x is less than negative 11, so less than would be to the left. And it also says x is greater than negative 14, greater than would be to the right. So here is your graph. To write interval notation, it would be parentheses, negative 14, comma, to negative 11, parentheses again. All right, here's another one. So like I said, think of this as two separate equations. So think of just this part here. Ignore the less than or equal to 3. So how would I solve the middle here? What do I want to get rid of first, the 5 or the 2? Well, I'd get rid of the 2 by multiplying by 2. That'll cancel that and that out. So I want to multiply by 2 over here and by 2 over here. So that gives me negative 6 less than 5 plus x less than or equal to 6. Now it's the same as the last problem, so subtract 5. Same thing, do it to both sides. So you get negative 11 and 1. And so your graph, we'll just go 1 and negative 11 here. And so we say x is greater, open circle, and we want a closed circle on 1, and they're going to be connected. Interval notation would be parentheses, negative 11, comma, to 1, bracket. All right, and our last one here. So we have 4 minus x is greater than or equal to 2, or 5c is greater than 15. Okay, so this is like solving two separate inequalities. So just kind of like we were doing before, except you can't do it in shortcuts like we did with the and ones. So for this first one here, we're going to subtract 4 because it's a positive 4. That leaves you with negative x is greater than or equal to negative 2. Divide by negative 1. Make sure when you divide by a negative, you flip the sign to get x is less than or equal to 2. Or, then we have to solve this one by dividing by 5. C is greater than 3. So here is your solution. To graph that then, 0, 1, 2, 3. We'd have open circle on 3, closed on 2. See, x is, this should be an x here, sorry. we should have the same variable. Okay, so x is less than or equal to 2, and x is greater than 3. So there is your graph for that. Interval notation then would be from negative infinity to 2 bracket, or from 3 to infinity parentheses. All right, and that is your compound inequalities. We will see you later. Make sure you took notes on the video.